Hello friends, Mr. Ben here, and today I would like to wish you a happy Earth Day. Hope you're having a wonderful day. So Earth Day is a celebration of that pale blue dot that we exist on out in the great big wide universe, and also a reminder that we need to take care of it because, well, we don't have any other place to call home. One of the most important resources on planet Earth, amongst the many, many natural resources that have kind of been the foundation of our civilization, is water. As you all know, we have to drink water on a regular basis in order to stay healthy. And while we're lucky here in the United States to have tap water in our homes that is reliably clean and safe to drink, that not all places on the earth have safe drinking water. And so today I want to go through a couple of tests that you can do to kind of check your water, but then talk about a couple of other tests that we're not going to do today, but that you can do on your own, and you'll see how in just a little bit. So let's get into it. So before we get started, let's just go over all of the things that I have here. So I have some data recording sheets. I got 2 of them because these are meant for 2 samples, but since we're going to also be using our tap water right out of the tap as a control, we're going to take 3 different samples. Right here we have a sample that we've added some citric acid, this so we can get a particular result, and same thing, we've added some salt to this so we can get a particular result. We also have our thermometer here to measure the temperature, and then we have our refractometer. This is actually what's going to measure the amount of salt in any of these solutions, and then we have our universal indicator pH test strips to figure out if something is acidic or basic. All right. So these are just some tests that you can do. In our backpacks we have other tests that you can do, but we're just going to focus on these today. So I'll take my control sample and I'll run through all the tests. So I'll start using my indicator paper. Okay. And so inside there are these different numbers associated with a color, and that will let us know what the pH value is. So pH is on what's called a logarithmic scale, which means that it's actually 10 times the difference from one to the next. And we'll take a look, and it looks like we'll just compare. Here we go. We'll just compare to each one, and it looks like it's at the number 7. And although if you don't really know pH, it doesn't make any sense, but 7 is actually neutral. It's in the very middle. Anything that is lower in value than that, so from 1 to 6, that's going to be acidic, and anything higher than that is going to be basic. So as acids are like lemon juice and apple juice, and bases are such as bleach. Okay, so we'll put that right here. Okay, that's that sample. All right, so now we're going to record that right there. We're going to check our neutral. Okay. So next we're going to take our temperature. So let's turn on our thermometer, and we'll place it inside of our sample. Wait a little bit. Make sure it's not touching any of the sides. And we've got 66.4. So I'm going to write that down. 66.4. I'm actually going to write control up here on the top. Okay. All right, so the last test that we have here is the refractometer. I wish I could actually show you what it looks like, but I have to look through the lens here to see the results on the inside. But the way this works is I'm going to take a small sample. I'm going to place it on the refractometer. I'm going to gently close it so I don't splash it everywhere, making sure that it covers the whole thing. And then I will just, and I'll kind of get down here a little bit so you can kind of see me. And I'm going to look through there, and as I would suspect from water directly out of the tap, it is at 0. There is no salt in here. So let me set that off to the side. Okay, and I will write down, I'll make the mark here at the 0 line. Okay. So now I will wipe this off because our next sample, we don't want it to be tainted or diluted by the other sample. All right. And now that I've finished that one and I have my results for the control, now I can move on to my next ones. So I'll do the same thing. I will take a test strip. I will place it inside my sample. Oh, and we can immediately see that this one is very different. And so we'll make a comparison here. I'm taking a look, and it looks kind of close to 4, but to me it looks a little bit closer to 3, maybe a 2. I don't know, it's hard. It's between a 3 and a 2. Maybe I'll go with a 2. Looks like it might be a 2. I think I'm going to go with a 3. I think it looks closer to a 3. All right, so I will write that down, check that on my recording sheet. Okay, so next I'll take the temperature and I'll place it inside, again making sure I'm not touching the walls. And I'll just wait to make sure the thermometer. So surprisingly, even though all these samples are at room temperature, this one is actually reading 66.6 instead of 66.4. Okay, so I'll write that down, 66.6. Okay, and last, we will put our sample on the refractometer. And put just a little bit there. Gently close. All right, and now I will look through, and oh, well this is supposed to be measuring salt, and I didn't put any salt into this from the tap water, but I am getting a result that's showing a little shy of 40. So that tells me that my refractometer doesn't actually measure salt, it doesn't measure salinity, it actually measures it looks for the dissolved contents and how that changes how the light bends. So in this context, I don't actually know if this is salt. I could be making a mistake by just relying on the refractometer to determine what this is. But there are other ways, for instance, and I don't necessarily recommend this, but we all know what salt tastes like, and so that is one way. When you're in the ocean, you can actually taste the salt, whereas when you're in fresh water, you don't taste the salt. So that's one way that I could tell, but again, I do not recommend using your mouth to do any kind of scientific exploration, just because you never know what kind of toxic substance might be in a sample. All right, so we're going to clear this off. All right. Okay, and now we're on to our last sample. Okay, put that up here. All right. So we'll take our paper. And so one thing about science experiments is, once you start to understand what's going on, you start wanting to make predictions. And so I think that because we haven't added anything other than salt to this tap water, that this should probably come up the same as our tap water. There is no acid or base in here as far as I know. So let's get that. And let's take a peek. And so, well, this is actually looking closer to a 6. The other one was a 7, and even now as I look at it, as it's been sitting there, it kind of got closer to an 8. But this one looks like it's a 6. Interesting results. So I will write that down, or rather check that off. Okay. All right, so since all of these are at room temperature, again, I'm going to kind of make a prediction. I think it's going to be somewhere close to 66 degrees. We had 66.4 and 66.6, so place that in there. Again, not touching the sides, just to make sure I don't get a result that's skewed. And, oh, so I had 66.2, but it jumped up to 66.6. I'm going to give it another couple seconds. And it hasn't changed, so I will write down 66.6. So it looks like we've been in pretty close proximity to each other, which makes sense since they are all in the same room, which is the same temperature. And now lastly, we will use our refractometer. We'll take that sample, we'll make sure we put just a little bit on there, not too much. Gently close it. Okay, and we'll take a peek through. And this one is just shy of 60. Clear that off. Place that there, and just shy of 60. All right. So now I can take a look at my different samples and I can make some determinations. Now I know ahead of time what these samples had in them, but if I didn't, I could now start making some guesses as to why the water is the way that it is. It's really important to our health to make sure that we have clean water. Now today I did tests of water where you could probably, just by tasting it, because acids have a sour taste and bases tend to have a kind of bitter taste, and so we kind of have a natural indicator in our body to make sure that we're not taking in stuff that might be toxic to us. If something is too sour, it might not be good for us. And if something is too bitter, well, that makes us think that we shouldn't eat that thing. And so there's kind of a way of protecting ourselves. Our taste buds are actually there to kind of help us determine that maybe this isn't something that we want to eat. Obviously, we'd be looking for salt. Salt is very important to the biology inside of us, making sure that everything functions well. Too much salt can be a bad thing, but too little salt means that your body isn't going to be able to function correctly. So, you know, in a hunter-gatherer sense, we would always be looking for salt, and so our taste buds, again, are able to help us kind of determine if we found a salt source, okay? But I want to point out that we have these backpacks here at the museum, and also at local libraries. We have them at Saratoga Public Library, also at Clifton Park, and I believe a few others. But this one in particular is for water quality tracking, and it actually has very different tests, because since we live in a freshwater environment, we won't really be checking for salinity, but you might be checking for pH, because fish and other aquatic animals have to live within certain pH ranges. They all have different tolerances, but you know, some are able to tolerate more acidic environments, some are able to tolerate more basic environments, but there is a range that they have to live within, and if it goes outside of that range, it can spell disaster for those organisms. So inside of this kit, there's a lot of different testing materials. Let me show you. There's a lot of different testing materials. We're looking for pH. We're looking for, actually I don't believe the coliform is in here. It was a very complicated test for this particular kit. But dissolved oxygen, nitrate, and phosphates. So oxygen, the thing that we breathe. Fish and aquatic animals, they also breathe oxygen. It's just that they need it to be in water. So they need their oxygen in water to get it. We need it in air, and we really can't do the other thing. We can't go into water and breathe in that water and then get the oxygen extracted from it. We would drown. And the same kind of a thing happens to an aquatic animal that relies on the oxygen from their water, is that when they're in air, they can't actually extract the oxygen from the air, on top of the fact that their body parts are designed to stay wet, and so as it dries out, they become less and less effective. There are some organisms that are able to kind of survive for much longer. There are some that can even go dormant when things dry out, but for the most part, most organisms have a very narrow window of different conditions that they can live within, and you know, as kind of the stewards of our environment, it is incumbent upon us to understand our impact on that environment, especially when it is detrimental to these organisms, because they don't have an understanding nor the capacity to change that environment to kind of rectify that situation. And so that's why it's just so important for us to take care of our planet and keep it nice. So on top of the testing kits, in this particular one, there's also a compass. There's a notebook to record what you found. There is a book about turtles, toads, frogs, and such. So it talks about aquatic environments. There's also scavenger hunts in here. There's a nature journal. There's a magnifying glass. There's lots of really cool goodies, some of which you actually, when you borrow these, you get to keep and take home. So we have a kind of nature journal that we want you to leave behind, so that others can read of your explorations and what you found. But inside our small pouch here, we actually have kind of a science notebook that you can take with you when you go. There's also some alcohol wipes in there to keep your hands clean. We have a first aid kit in case something happens. Hopefully not, but if you get a little cut, we want to make sure that you have that. All right. And then there's just a lot of other little goodies, and this is just the one of the backpacks. So we have this one, which is all about water, and then we have some that are about mammals, and then others that are about birds. So if you're interested in exploring out in the wild, and you want to kind of go out there with that scientific inquiry in mind, then you can stop by the museum once we're open. Unfortunately for that, we're members only on that, so you know, it's a good idea to get a membership anyways, so there's an extra bonus that comes with it. But if you are looking for these backpacks, you can get them at your local libraries, as I had mentioned, and those can be taken out and borrowed by anybody. And like I said, there's some goodies in there for you to take home with you, but also there's just a lot of fun stuff to look at and kind of explore your world. So again, happy Earth Day, friends, and until next time.
Hi, everybody, and happy Earth Day. My name is Celia, and I'm an intern here at MiSci. And today I'm going to walk you guys through an activity where we're going to kind of measure our carbon footprint and get an idea of how our everyday actions have an impact on our planet and what we can do to lessen that impact and better take care of our planet and keep it healthy. So if you don't know what a carbon footprint is, it's basically a way that we can measure the impact of our own actions on our planet based on how much greenhouse gases they emit. If you don't know what greenhouse gases are, you probably know that the sun supports life on Earth by giving its heat and radiating energy that sustain life on Earth, keep everybody warm, and keep the weather and climate stable. And the Earth actually absorbs a lot of the energy from the sun and uses it to sustain life. And the rest of the energy, it reflects back out into space. But certain gases called greenhouse gases, like carbon dioxide, actually absorb that energy and trap it in the Earth's atmosphere, creating a lot of excess heat that creates climate change, which has a ton of negative effects on our planet. It can increase natural disasters, storms, and flooding. It can make heat waves that have detrimental effects on farmers, our crops, and on the animals. It can also diminish ecosystems like the ice caps, which start to melt so that animals who live there don't have a habitat anymore. And when those ice caps melt, they cause the ocean levels to rise, which causes flooding and all sorts of weather disasters for us. But whether we realize it or not, our own actions actually have an impact on the carbon dioxide that we emit as a planet. And we are producing greenhouse gases with the activities that we do day to day. And the amount of greenhouse gases that we emit is what's called our carbon footprint. So now that we know what our carbon footprints are, we're going to do an activity that's going to let us measure that carbon footprint and give us an idea of the steps that we can take to lessen our footprint so that we can treat the planet better and create a better environment for everybody. So you should have one of these carbon footprint worksheets, which I'm going to fill out with you. And you're going to need a few different colored markers. We're going to use red, blue, green, and brown. If you don't have those colors, you can get different colors, but they're each going to represent a theme or group of activities that are the leading contributors to your carbon footprint, which come from energy use in your home, energy use from transportation, your personal habits, and your recycling and waste habits. So now that you should have your worksheet out, I am going to start walking you through this activity, and I'm going to show you my worksheet that I'm going to work on with you. I'm going to read a series of statements that describe some activity or trait of your home, your transportation habits, your personal habits. And if you agree with that statement, or if that applies to your life, then you're going to color in a ring on your worksheet. So we're going to start with our red color, or whichever color is going to represent housing and home energy use. So the first statement is, if you live in a single family home, you should color 4 rings red on your worksheet. And if you live in an apartment or other type of home, you should color 2 rings red. Since I live in a single family home, I'm going to color 4 rings red. So that's going to be these 4 here. And this doesn't have to be perfect. It's just to give us an idea of our carbon footprint. So we'll wait while everybody colors these in. Yours might look a lot nicer than mine. But we're just trying to see how big our carbon footprint is and where that energy is coming from. Great. So the next statement is, if you don't use energy efficient light bulbs, such as compact fluorescent light bulbs or LED light bulbs, which use less energy than like regular incandescent light bulbs do, then you should color in 1 more red ring. And since I do use energy efficient light bulbs, I'm not going to color another ring. If your home doesn't have a programmable thermostat, you should color one more ring red. My home does, so I will not color that one in. If you're not familiar with Energy Star appliance rating systems, which we will talk about later, but if you don't know what that is, color one more ring red. And since I was not familiar with that before starting this, I'm going to color one more ring. This does not have to be pretty. Okay. For this next section, if you agree with one of these statements, you should color a ring in blue. This is all about transportation habits. So for every small car in your family, you should color one ring blue. So small cars are maybe only for a few passengers, not a big SUV or minivan, things like that. And if you have a medium or large car in your family, you should color two rings blue. In my family, I have two small cars, so I colored two rings blue. The next statement is if you don't regularly change the air filter on your car, or if your parents don't regularly change the air filter in your car or check the tire pressure, you should color one more ring blue. And for every airplane trip you've taken in the past year, you should color one more ring blue. So I went on one trip this year on an airplane, so I would color one ring blue. If you went on two, color two. And at the end of that, you should have a few more blue rings. And now we're going to switch to a green marker, which is going to cover our personal habits. So things like the food you eat, do you shut off the water when you brush your teeth, habits like that. So the first one is if you're a vegetarian, you should color one green ring. And if you're not a vegetarian, you should color two green rings. So if you don't eat meat in your household, you can color one ring green. And if you do, you can color two. I am a vegetarian, so I would only color one ring green. If you are not, you color two, because meat eating and the production of meat can have a pretty harmful effect on our environment, which we'll talk about after. If you never eat organic food, you should color one or more ring green. I sometimes eat organic food, so I won't color a ring green. Or maybe I would color one ring green. If you never eat it, maybe you would color more. If you only eat organic food, maybe don't color any. If you take baths, run the faucet while brushing your teeth or washing the dishes, or water your lawn several times a week, or if your parents water your lawn multiple times a week, or if you have one of those automatic sprinklers, you're going to color one extra ring green. So this is things like turning the faucet off while you're brushing your teeth. It's a great way to reduce your water use in your home, or taking showers instead of baths, or taking shorter showers. All of that is great. And those are all of our personal habits with the green marker. So we're going to take a switch over to the brown marker for your recycling and waste habits. So if you usually recycle your household trash, or if you're in your house, you've got a recycle bin, you can color one ring brown. And if you don't recycle in your house, then you can color two rings brown. And for the next one, if you never compost your yard and kitchen waste, you can color one or more rings brown. If you don't know what composting is, that's saving your food waste, putting it in a big pile or in a composter, and leaving it alone until it eventually turns into soil that you can use in your garden or on your lawn. And this reduces the waste that you throw into the landfills. So if you never compost, you can color maybe a few rings brown. If you do it sometimes, maybe just one. Or if you are an avid composter in your house, then you can color no rings brown. So here's my finished worksheet. So because we use these different colors, you can kind of see, one, how big your carbon footprint is. So mine doesn't go all the way to the outside. Maybe yours does. Maybe yours is much smaller than mine. The size of it is a good indicator of how much carbon dioxide your everyday actions are emitting. It doesn't tell you exactly, but it gives you an idea of how big your carbon footprint is. And you can use these different colors to see which areas of your habits are contributing most to your carbon footprint. So for me, the biggest areas here are the red and blue. So that means a lot of my habits in the home and with transportation are not the best and are maybe contributing more to my carbon footprint. And those are areas that I can improve, but my green and brown rings are pretty small. So in terms of my smaller personal habits, my food habits, my recycling habits, I'm doing pretty good. And while you finish coloring or take a look at your worksheet, we're going to talk a little bit about the ways that you can reduce the size of this carbon footprint. Looking at our red area for home and housing energy use, you'll notice that we asked about single versus multi-family homes. So single family homes generally use more energy for less people. But even if you live in a single family home or live somewhere else, there's a ton of different ways that you can reduce your carbon footprint that don't require moving. One is to reduce your light bulb, is to replace your light bulbs with more energy efficient light bulbs like compact fluorescent or LED when you're in the store to replace them. They use less energy than regular incandescent light bulbs do. And they'll help you save money because they last longer. We also talked about programmable thermostats. These are a little fancier than regular thermostats because they allow you to program it so that it will heat and cool your home automatically, depending on your needs, so that you're not using more energy than you need to heat an already warm home, things like that. And it wastes a lot less energy and reduces your carbon footprint. We also talked about Energy Star rated appliances. So this is just a little rating that you'll see on appliances in the store, like refrigerators and stoves and microwaves, that tells you that it's been certified as an appliance that helps you save energy. So that's a great way to reduce your carbon footprint if you're looking to replace things. Next, we're going to look at our blue ring for transportation. So one of the ways you can reduce these is by carpooling and reducing the times that you drive someplace on your own. So if you carpool and pick up a friend on your way to school. Cars that are also properly maintained, so things like checking your tire pressure and replacing car filters if you ask your parents to do that, generally need to use less energy because they have to do less work to drive properly. And all modes of transportation are going to consume energy and impact your carbon footprint, but you can do things like riding a bike or walking places that are close to reduce your carbon footprint. And we're going to then move on to our personal habits, the green ring here. So we talked about whether you're a vegetarian or not. In general, distributing food from places like farms and grocery stores with trucks and factories uses a lot of energy and produces a lot of carbon dioxide. But a large portion of that comes from producing meat products and transporting meat products from farms to your grocery store to your home. So vegetarian diets tend to have a lower carbon footprint. If you eat less meat, or you don't even have to go full vegetarian, but if you eat one meatless meal a week, that's going to significantly reduce your carbon footprint. We also want to reduce the water usage in our homes. So things like turning off the tap when you brush your teeth. And recycling is one that we've all heard in this brown ring. Recycling, reducing food waste by composting, all of that is great. And that's the activity. So if you want to keep this worksheet or keep another copy and try it again in like a month after you've maybe made some of these changes, so you can keep track of your progress, is really, really helpful and a great way to motivate you to reduce your carbon footprint and treat the planet a little better. And just to finish off today, I wanted to tell you about some of the things we have coming up at MiSci if you want to learn a little bit more. So one thing that we have coming up are our summer classes for students when you're on for summer break. And you can take a look at the MiSci website. If you're interested in signing up for summer classes, you can click here on programs and break week and summer classes. And you'll find a button to register for the summer classes. And you can also see the full list of topics and activities that we have going on. And we'll teach you a little bit more about the Earth and climate action too. And as another event we have coming up is the Big Bang Gala on Friday, May 6th. And if you click here right from the home page, you can purchase tickets to the event right here. We're also celebrating the Apollo 11 manned mission to land on the moon, which was our first mission to the moon in 1969. And we're opening a new Be the Astronaut exhibit that's going to explore some of those challenges and excitement of spaceflight and let you see what it was like to be an astronaut on that mission. Those are some of the things that we have coming up here at MiSci. We're really excited to see you here. I hope you had fun doing this activity today. Thanks everyone. Happy Earth Day.